All right, welcome back. We are continuing our look at counting. Yes, it is that important. It might not seem like it on face value, but I promise you, and you'll see it by the semester's end, that we really just can't talk about probability meaningfully or in depth, really, unless we do some work in combinations. So we've done, I'm sorry, not just combinations, but permutations as well, just the various counting techniques. Because as you'll see working through some of these problems, as we'll see in class, as we'll see in these videos, it's just not feasible to sit down and list all the possible configurations for something. It's just not feasible. Possible? Yes. Useful? No. What is going to be useful for us, especially in the probability discussion, is looking at counting techniques. So in the previous series, that was this, I guess this is actually chapter 12, whoopsie. The 12.1 stuff was permutations where order mattered. And now we're going to talk about combinations where order doesn't matter. So really, this is something you've got to decide based on your situation. Sometimes order matters, right? When I'm entering a password, then even if I get the numbers right, but I get it in the wrong order, that's not good enough, right? Order matters for a password. Order matters for a license plate. Order matters for finishers in a race. Order matters if I'm picking officers for a committee, right? President, vice president, secretary, treasurer. Order matters when you're making those selections. That said, though, order doesn't always matter, right? When you're picking lotto numbers, uh, the pick fives, the pick threes, even the Powerball to an extent, the order you pick the numbers doesn't matter as long as you've picked the right numbers, right? If you're playing cards, be it poker or blackjack or something like that, the order you get the cards doesn't matter because you're allowed to move cards around in your hand. So there are times where order doesn't matter and times when it does. And we will look at, well, we've already looked at order matters, so obviously we will look at where order doesn't matter, and we'll see those differences. So combinations, simply put, is like the permutation count, but less. You start looking at redundancies and removing redundancies. So my example for us to start with when we're talking about combinations is actually something where it's kind of a half and half one. I'm looking at the arrangements of the letters in the word book, BOOK. Now I've got two O's in there. And just for clarity's sake, I've got one in bold font here. Obviously, we don't normally embold one letter of a word, but I've done it here just to illustrate that for all of these arrangements, I always have a duplicate that is functionally the same, right? BOOK is the same as BOOK, right? It's the same word, same arrangement of letters. So even though the permutations formula would give me 24 permutations, half of those are redundant. And that's because I have two O's. So what we'll do, I'm sorry, I skipped ahead a little bit. What we will do in calculating combinations is in essence take the number of permutations and divide away the number of repetitions or the variety of repetitions we might have. So if you remember the formula for the permutations, it was n factorial over n minus r factorial. Note how we are now dividing by one more thing. And that r factorial, that is the amount of redundancies we have when we start saying order no longer matters. That's how those two are related. Also, just for your own sake here, this formula has a couple of names. Sometimes we write it like this in what's called binomial representation, or we'll write it as n choose r. In any event, it's always pronounced n choose r. And this is the formula. So let me end with these examples here. You might want to pause the video before you see the next one and just see if you can't work these through. How would you calculate the following? 6 choose 2, 5 choose 3, 10 choose 5, and 100 choose 100 using, again, this formula. So let's work through these, and I'll see you in the next video.